Hello everyone, welcome again to this lesson. Today we are going to differentiate the sign of sin x using first principles. Okay, so this is the formula for differentiation from first principles. Okay, divide the x with limit h tending to 0, f into x plus h minus f of x over h. Okay, this is the formula for differentiation from first principles. So in order for us to use this formula, we need to get what f into bracket x plus h is, and we need to know what f of x is. Okay, so from our equation here, which is y is equals to sine of x, directly from this we know that f of x is sine of x. Okay, just by this equation directly we can see that f of x is sine of x. This and this are the same thing. Okay, so to find f of x plus h, all you need to do is, where there is x, you replace with this. Okay, so you'll have sine, and instead of x we'll write x plus h. We can now chug and plug it in our equation. Okay, so this means that the differentiation divide the x with the limit h tending to 0 is equal to f of x plus h. F of x plus h is here. Instead of writing f of x plus h, we write sine x plus h. Okay, sine x plus h minus f of x. F of x is sine x, and that is divided by h. Okay, that is what we now have. Now if you look at, we want to expand this. This is a compound angle, so we need to expand it. So from trigonometry we know that if you have sine of a plus b, so this is the same, this will be identical to, if you expand it, it will be sine a cos b plus sine b cos a, from trigonometry. Okay, trigonometry, we know that if you have sine into bracket a plus b, if you expand this you'll get sine a cos b plus sine b cos a. Okay, so but in our case it is x plus h, so we will have sine x cos h plus sine h cos x. Okay, and this is limit h is tending to 0, the limit h tending to 0 minus sine x. Okay, so we have the numerator covered and it's divided with h. Okay, so the next step, what I want to do is, I want to bring this sine x, I want to put it together with this other sine x. Okay, so what I'll do, it will be that sine x cos h, bring this plus sine h cos x over h. Okay, so bring this, I've brought these two sine x together. Okay, but it's still the same thing. I've just brought the sine x's together. Okay, limit h tending to 0. So since we have this, we can pull out, since sin x is common here, we can pull out the sin x. Okay, so with the limit h tending to 0, pull out the sin x, to bracket we now have cos h minus 1 plus sin h cos x, and we can put the denominator separately. Okay, h here, and we also have h there. Okay, good. Now what we need to do, it is with you need to separate the h. Here is what we have to do. So we'll have sine of x, and here we have limit. Remember, limit h is tending to 0 of cos h minus 1, cos h minus 1 divided by h plus, pull out the cos x, and here we have limit h tending to 0 of sin x, sin h rather, over h. Okay, that is what we now have. Now if you look at this, limit h tending to, from this can be, it can be proven that limit h tending to 0 of course h minus 1 over h is equal to 0. Okay, it can be proven that limit of h tending to 0 of course h minus 1 over h is equal to 0, and limit h tending to 0 of sine h over h is equal to 1. Okay, it can be proven, but I'm giving you this without proof, but just know that limit of h tending to 0 of course h minus 1 over h is equal to 0, and limit of h tending to 0 of sine h over h is 1. Okay, so with that knowledge we can now replace it here. So we now have, so if we replace this part, this will be we'll have sine x. Remember, limit of h tending to 0 of course h minus 1 over h is 0, so place there 0 plus cos x, and what do we have here? Limit of h tending to 0 of sine h of h is equal to 1. So that leaves us with cos x, and that shows that if we differentiate sine x you'll get cos x. Okay, so that is the answer, the differentiation of sine x using first principles, from first principles. Okay, this first, don't worry about it, I will show you in another video how we prove that the limit of h tending to 0 of cos h minus 1 over h is equal to 0. Okay, and limit of h tending to 0 of sine h over h is equal to 1. It can be proven. So I know this is the tricky part, but don't worry, just know that that is it. Okay, so thank you for watching. This is Understanding Math.